And today on the bench we have a Johnson Messenger 4730. So it's a 40 channel AM sideband radio. It's in pretty good condition. Cover, grab it here. It's not too worse for wear. They kind of had a matte finish on these, but they should clean up pretty good. No big, I mean, it's kind of hard actually to dent or ding these things. Just look how thick the sheet metal is on these. These things are almost plate steel. So I always jokingly tell people, if there's one radio you never want to drop on your foot, it's a Johnson. If you want broken toes, this is the radio to do it. But the customer sent this one in. He had just recently purchased this. I think it was on eBay, said online, but I think it might have been on eBay. But he said the seller said that the radio worked. He had apparently, I guess there's a video on YouTube of it showing that it actually worked in receive. Now, he received the radio, and it doesn't do anything. So he sent it to me to get it repaired. Now, first thing I do, always take the cover off first. And the first thing I noticed was, somebody's done a lot of really blobby-looking solder work on the bottom of this thing. And actually, and I'll show you in a minute, the more I'm beginning to wonder, maybe they used acid core solder. But, so then as long as everything looked okay, I went ahead and powered it up, and the radio did turn on, but no receive, no transmit. Now, seeing that there had been a lot of solder work on this, but no visible signs that any components have ever been replaced, bad solder joints. First thing that pops into my head. Now, these radios are early double-sided circuit boards, but they do not have through-plated holes. What they basically have is, you could almost think of it as a small nail. So from the top side, it's made out of copper, tinned copper, but it kind of looks like a nail. So just take a piece of heavy gauge copper wire, basically, smash it flat on one side. It gets dropped down. Jesus, let me get a drink of coffee here. There, that's better. Basically, they drop it down through the hole, and then it gets soldered on this side and on the other side. And then that makes the connection between the traces on the top and the bottom side of the board. That in itself can cause a lot of stress. It's almost impossible for the solder joint to break loose on the top side because it's got that flat surface. So when the board expands, and no matter how, now these aren't laboratory, this isn't an instrument. Well, don't get me wrong, it's a Johnson Messenger, one of the best built radios there are, but it's not a circuit board you're going to find in a laboratory instrument or like test equipment or aircraft and whatnot. So the circuit board itself is going to have some expansion and contraction. All boards have that. But like I say, having that flat nail head on the top, if a solder joint's going to pull out, fortunately, it's usually going to be on the bottom side, which is the side you can get to. If they had stuck them through from the bottom to the top, that would be a royal pain in the hoo-ha, because you would have to get to anywhere where you see a little silver dot. Okay, that's solder right there. That's actually one of those pass-throughs. There's one of those little kind of like nail critters in a hole there, and it's soldered on the top and bottom of the board. And you can see there's circuit traces here on the top. They're all over the place. But I get the feeling it's a bad solder joint, and like I say, the solder is kind of globbed up. I'm having a hard time even seeing some of the connections to see if they're actually good or bad. So it's an old radio. The electrolytic capacitors need to be replaced in this thing, and in addition to the electrolytic capacitors, this also has CCS of another form. So CCS, crappy cap syndrome. But it's not electrolytics, it's non-polarized, the green polydip capacitors. Done a whole nother video on that showing how these things disintegrate. Actually, here's some of them already pulled out. Let's see, is this one split open? It's all, you can see how it's kind of fuzzy looking and whatnot. Now, that's not fungus, it's actually the green poly part of it is actually disintegrating. And you can see, get the light right, you can see there's a crack in it right there. That line, I can actually, I don't know if I can get the light right where you can see it. I'll never get it in focus on that little guy. But if I look down in that crack, I can actually see the aluminum inside the capacitor. And that's the problem. These were sealed in this coating to environmentally seal these from the outside air, so moisture can't get in here, because that is aluminum foil in there. So just like an electrolytic capacitor, it can oxidize. Now that it's exposed to the atmosphere, oxygen and moisture can get in there and cause the aluminum to corrode, and it's just going to cause problems. So I need to change those. Now, luckily in this radio, all of the green poly-dip capacitors are not this style. So if you ever look at these things, the only ones I ever see go bad are these. I'm going to get to focus. See, it says Silk up there at the top. S-I-L-K. Those are the only ones I've ever seen go bad. All of the rest of them in this radio that don't have anybody's brand name on it, they just have a value, they never go bad. These ones that had Silk written on them, every Silk capacitor I've seen for years looks just like this. And some of these actually are fairly bad in this radio. Actually, get back here and close to the final section in this thing. Where was that one? Right there. You can see that one. It's split open. It's physically, the chunk's getting ready to fall out of that thing. It's so bad. But yeah, so like that one, there's one there's one there. But like I say, you look up here, there's a lot of them. It's very easy to see which ones are bad. There's a fuzzy looking one, there's a fuzzy looking one. All the rest of them are still nice and shiny. That's because they're not, this green coating on them's not decomposing. That's anything I can figure happens to this stuff. It kind of gets soft and mushy. Occasionally you'll see that white kind of like crystalline structure. Whatever that is it decomposes. It's like it's outgassing, I guess. You'll actually see that crystalline stuff stuck to all of the surrounding components, because I guess not a chemist, but I guess as that decomposes the gas, it crystallizes on surrounding components. But yeah, we need to get those out of here. But like I say, luckily there's not. All the rest of these are just fine. There's nothing wrong with those, so no reason to change them. But the electrolytic caps, they all need to go. So as you can see by the pile of parts over here, I'm already starting to pull them out. So that's pretty much everything back here in this section that needs to be replaced. All the electrolytics and a couple of those green poly dip caps. And then the underside of the board here, you can see how the board, I don't know what it is, just everything in this area kind of has you can see it's even pitted through the silk screening, and it's starting to slightly corrode the circuit traces. I'm not sure if somebody used acid core solder or some type of highly activated solder to do some reflow work on this, because you can see it's this gloopy, gloppy solder work. Yeah, not the best looking stuff, and it's fairly obvious to see everywhere where somebody came in here and worked on it. All the factory ones are nice, nice little fillets on them. So what I need to do is, not knowing what this gunk is they have on here, and it's kind of, normally I don't do radios like this, just take out take out all the capacitors in an area. Main reason I'm doing that is I want to try and get as many of the components that I need to take out anyhow out. Now I can come in here with a larger, and with my desoldering iron, they make a tip called the flow desolder tip. So it's a lot thicker wall, and what it's meant for, it's actually designed for cleaning off surface mount component traces. But what I can do is, now that I have the components out, I can come in here and basically go over this board, all those areas, and I can really clean off all of that solder and that nasty flux there, try and basically sanitize the board. Because whatever that is, I got to get it off. I can't let it in here to corrode these circuit traces, or there's just going to be more problems down the road somewhere. But, so, let me get back to working on this little guy here. Now, one thing, when I did turn this on originally, like I said, I turned it on, did not have receiver transmit. I tweaked the chassis, so you basically grabbed it like this and just kind of gave it a little, and flexed it, and receive came back. Keyed to microphone, receive, let go, receive went away. Flex the chassis again, it came back. Push on the board, yeah, occasionally it would pop in. So yeah, another good sign, bad solder joints. Now, AM transmit power is I don't want to say it's non-existent, but we're talking less than a quarter watt, probably between a 1/16 of a watt and a quarter watt of output power on AM. That doesn't concern me too much because sideband power, on the other hand, it was like 10 or 11 watts of sideband power. So as long as I have fairly good sideband power, and I haven't done anything to the radios, that's still with the original caps, haven't done an alignment on it yet, that tells me that, the pre-driver, the driver, the final transistors, there's no problem in the amplification, the final amplification circuit. It's elsewhere in the radio. So, that's why, it shouldn't be too much. It may be solder joint related. That's why I want to do this cap job, get those circuit traces cleaned up, and do the cap job before I go diagnosing that problem. I don't want to go wasting a bunch of time trying to diagnose why it has low AM only, or, low transmit power on AM only, just to find it's a bad cap, bad solder joint, or something like that. It just, you try and be frugal with your time. Use it sparingly. So anyhow, let me get back to cleaning this board off here, replacing parts. Now, I got to stick a power cord on this thing yet. It's been spliced, and it's not very long to start with. The only thing holding the fuse holder together is tape, and actually there's 2 butt connectors in the ground wire here. I mean, really, people? Why? Hey, I've seen, back when I used to be a truck mechanic, I would see stuff like this. Piece of wire, butt connector, 3 or 4 inches of wire, butt connector, another 3 or 4 inches of wire, butt connector. And you'd see that for like 3 or 4 feet of wire, and there'd be 15 or 20 butt connectors in there. I mean, really? Just cut it off here, put a butt connector here, and one solid piece of wire. People never cease to amaze me. So, anyhow, let me get back to work on this, and I shall return. Okay, so you can see it's up and running now. So I've replaced all the electrolytic capacitors. I've replaced the green polydip capacitors that were basically falling apart. So if you remember in the first part, I showed you how the ones that are marked Silk, that company, and you don't even need to look for the name. Just look in the radio, you'll see them. They're disintegrating, and they'll obviously look different than all the rest of the green polydips in there. But those were replaced. In this radio, that was 2 different values of capacitors. It was like 8 or 9 caps total, I think, something like that. But those were replaced, and there's no reason to change the other ones. They're perfectly fine. They're not cracked. I've never seen the other ones break open. It's just those ones that were made by Silk, yeah, whatever they used to coat those things, it disintegrates. Other than that, replace the upper sideband light bulb. I did resolder a bunch of the pass-throughs. So, because remember, this is a double-sided circuit board, but does not have the through-plated holes. So they use a little piece of wire. After I got done doing a cap job, some of the problems it had went away, but the receive, if you'd tap on the chassis or, try and flex the frame a little bit, yeah, it would come in, come and go as it pleased. So really close inspection, I actually found one of them was actually bad on the top side, which usually they're not bad up here, but it does happen. So I've rechecked all those, actually resoldered a couple of them on the top side here, and that seems to have taken care of that problem. And I think that was about it. Now, if you're not familiar with these radios, and I'm not sure if I mentioned it earlier in the first section before I did all the work to this, now this is a Messenger 4730. But if you're familiar with the Viking 4740, it's basically the same exact radio. The only real difference is the channel selector and the channel selector switch and the display, where this is a very early 40 channel radio. Okay, and it has a manual, turn the power on so you can see it, it has the manual rotary dial, where the later 4740 had a LED digital display. Other than that, on the inside, they're basically the same radio. This, pretty much everything else you see in here is pretty much the same. The only other thing I've done, actually didn't do it to the radio, that was to make the customer a couple of jumper cords. So Johnson's, yeah, them and their bird brain idea of putting the microphone cord in the back of the radio. What are you going to do? It's where it is. There's not much you can do about that. I hate that. I know most people that own these radios complain about, why is the mic jack in the back? You're asking the wrong person. I didn't design it. They did that with their amateur radios too. But it's very simple to fix. Just make yourself up a little jumper cord. So take a piece of, I just use straight mic cord. I buy this stuff by the roll. But a piece of microphone cord, take a 4-pin, so this isn't actually the plug, this is a 4-pin socket, but it's meant to be installed on a cord. And then just take a microphone plug, a 5-pin, one of the 5-pin DIN twist lock plugs, and just make yourself up a little jumper cable. Now you could put the DIN plug here, but I specifically, the customer, I said, would you like me to actually put a 4-pin wired for like Cobra, Ranger, Galaxy on here? Because that's what most people have nowadays, because that's what most radios, if they're 4-pin, they're usually that's standardized, pretty much standard between a lot of different companies. And that's what a lot of people will do. They'll make adapters so they only really need one microphone, and then they can use it with all of their radios. They'll just use their adapter, plugs or adapter cords like this. Now this one was made long, reason being I made 2 of them because he actually wants to use one with another radio. But this way, the cord, as you can see, comes the whole way to the front of the radio. So it's long enough to reach the front, and then he can just lay this on the bench or whatever he's going to do with it. But that gets you up to the front of the radio. That way you're not running out of your normal cord. So yeah, a couple adapter cables, that fixes up the old problem of the mic cord being stuck in the back of the radio. So there you go. There's another up and running Johnson radio. I don't think I've ever done a video on a 4730 before. Like I say, basically the same as the 4740, just different indicators and channel selector switch. But yep, nice radios. And if you ever get one of these, just remember one thing: don't drop it on your foot. You're going to break your toes. Because remember, this thing has the bulletproof armor-plated radio cover. The one thing Johnsons were known for. So there you go.